Hi calculus friends. I'm making a little video about section 4.1 number 2 because this is a good example of finding and classifying the critical points of a function. It will give us some practice doing some algebra, and also it will be a place where I can show you the first derivative test in a little more complicated version than we've seen in class before. So section 4.1 number 2 asks to find and classify the critical points of this function 4x to the 6th times 2 minus x to the 7th. So clearly the first thing that we want to do is figure out what the derivative is. We're going to need the product rule for that. So f prime of x is going to be the first function left alone multiplied by the derivative of the second function using the chain rule there. And then the derivative of the first function, so 24x to the 5th, times the second function left alone, so 2 minus x to the 7th. Now, what I would like to do is I would like to figure out the zeros of the derivative. I would like to use the zero product property for that says that if you have things multiplied together and it all equals 0, then one or the other of the things has to be 0. But right now, we are not in a form where we have things multiplied together. We actually have two terms added together. So what I'm going to do is I'm going to try to factor some things out of those two terms so that we can write this as a product of nicer things to deal with. So the question that I'm going to ask is, what do these two terms have in common? I think you'll agree with me that they both have some x's, and in fact we can pull out 5 of those x's. And then also they have 2 minus x's. Looks like I can get away with taking out 6 of those. So here is 2 minus x to the 6th. And then what's left over is this 4, one of those x's, and then this 7, this negative 1, right? So that'll be negative 28x. And then what's left here is, let's see, the 24, that got pulled out, and then all but one of those. So 24 times 2 minus x. So I think that you will agree with me that what we have is x to the 5th times 2 minus x to the 6th times, let's see, negative 28x plus 48 minus 24 should be whatever 28 plus 24 is, 52. So 48 minus 52x. Okay, so far so good. Now we can use the zero product property. Since this whole thing is supposed to equal 0, one or the other of these three factors has to equal 0. So either x to the 5th equals 0, or 2 minus x to the 6th equals 0, or 48 minus 52x equals 0. So here we get x equals 0, here we get x equals 2, and here we get x equals 48 over 52, which, let's see what that is. Gonna plug it into my calculator. So 48 divided by 52 is, call it 0.9231. So far so good. Now we have the locations of our critical points. I'm now going to erase the board because I need some more board space. Okay, we're back. I've erased the board. Up here I've put the derivative of the function as well as its 3 critical points that we found before we erased the board. So now what's going to happen is these 3 critical points chop up the number line into 4 test intervals. Let's see how that happens. So here is a number line. 0 is like here. The second one, 0.9321. Oops, excuse me. 9231. There we go. And then 2. So now we have 1, 2, 3, 4 test intervals. What we're going to do is we're going to take an x value in each of those 4 test intervals and plug it in and see what happens. One thing that I'm going to point out is, first of all, that this factor, since it's to the 6th power, is always going to be positive no matter what we plug into it, right? no matter what this thing inside the 6th power is, once we raise it to the 6th power, we get a positive answer out. So I'm just going to mark this part as always being positive. So now, let's take some number less than 0 and plug it into our derivative and see if we get a positive thing or a negative thing. So we'll have some negative number to the 5th power is going to be negative. We decided this middle part is always positive. And then, so maybe I have a negative 1 here. Well, so then 48 plus 52 is certainly going to be a positive number. So I have a negative times a positive, which is negative overall, which means that my function is decreasing before 0. Now let's take something in this interval. So now I have a positive number to the 5th power will be positive. The middle part is always positive as we decided earlier. And now I have maybe a half here. So 48 minus half of 52 is certainly going to be positive as well. So positive is positive overall. So the function is increasing between 0 and the second critical point. Now let's take something between this one and 2, like maybe 1.5. This will be positive, this will be positive, this will now be negative because now we are past the point where this becomes 0. So we have positive, negative. Multiply those together and we get negative overall, which means the function is decreasing on that interval. And now if we take something larger than 2, we'll have positive, and negative again, which means that overall we have a negative answer, which means the function is decreasing there. Now we can read off from our sign diagram here what the kinds of critical points are. Since here at 0, the function goes from decreasing to increasing, 0 is a minimum. Here at 0.9231, the function goes from increasing to decreasing, and so 0.9231 is the location of a maximum. Here at 2, something weird is happening. We're going from decreasing to decreasing. So that means that the function looks something like this, and we have what we call a horizontal point of inflection. It's neither a minimum nor a maximum. So there we go. We have managed to find all the critical points and classify each one as either a maximum or a minimum or neither using the first derivative.